Okay, hopefully this is going to come across in some way that's actually useful, as in hopefully you can hear me and hopefully you can see what I'm doing in some meaningful way. Okay, so here's this problem for the workbook that I think we messed up, or I messed up a little bit on, and I want to do this over again. So essentially the key here is that we're actually always going to want to make these be 0 on the right hand side. What I mean by that is if we look at the problem that we did, x squared less than 9, if I just left it like this and then asked for the key values, then we would only see x squared and say, oh, so my key values are 0, because that's when x squared is equal to 0. And then just say, oh, it looks like it's 0 then. But we know better, because if we subtract 9 over here, right, we can see this and see the key values of this thing are actually x's plus or minus 3. And in fact, the other approach is to take the square root of both sides and say x is less than the square root of 9 and x is greater than the negative square root of 9. And then those both turn into 3 respectively, kind of giving us the same thing as if we do the key values with 3. So the idea here is that this key value approach only really works out if we're setting it equal to 0. So that means that we're going to subtract 3 from both sides of this equation. So we're going to get 2x minus 7 over x minus 5 minus 3 is less than or equal to 0. And now we're going to try and handle this. Well, as always, whenever I have fractions and I want to do some difference or addition, I need to get common denominators. So how do I combine this 3 with the other fraction? I'm going to multiply top and bottom by x minus 5. So that way I get x minus 5 in the denominator, so that both of them have the same denominator, right? So all of my denominators need to be x minus 5 so that I can actually take this difference here. And then on top, I'm going to get, well, 3 times x minus 5, but I want to be extra careful and remind us we need to distribute this, so that turns into 3x, and then 3 times negative 5 gives me negative 15, and then I haven't really done anything with this fraction yet. Okay, so now that they both have the same denominator, I can go ahead and combine these, but let's be careful. I am subtracting the right fraction from the left, so I need to distribute this minus sign to both pieces, right? So really I want negative 3x plus 15 once we distribute that. So 2x minus 3x gives me negative 1x. 2 minus 3 is negative 1. And then negative 7 plus 15 gives me positive 8. So then I have negative x plus 8 over x minus 5 less than or equal to 0. Now this key values conversation can really start. And now we ask when is I just want to dot the I, negative x plus 8 over x minus 5, 0 or undefined. Undefined. Well, we're 0 whenever the top part is 0. So negative x plus 8 equals 0. That tells us that negative x is equal to negative 8. So then x is positive 8, right? Multiply both sides by the negative 1, or divide both sides by negative 1, whatever makes sense. And so that is where that function, or that fraction, is equal to 0, but we're undefined if the denominator equals 0. right? Undefined. It's meant to be an E. Undefined when -5 or x minus 5 equals 0, aka that just means x equals +5. So now we have our two key values, +5 and +8. That 5 looked really bad. Okay, +5 and +8. So we're cutting the number line at these 2 points, and I'm going to make my intervals appropriately, 5 to 8 for that interval, everything in between here. And then to the right, we're going 8 to infinity. And then on the left, everything to the left of 5. So we're going to go from -infinity all the way to 5. Very good. Now we can test values here, right? Pick a representative value in the section to get to see what the fraction does in each section. So a nice number between 5 and 8 might be 6 or 7, you know, depending on your preference, I guess. A nice number between 8 and infinity could be 10. And a nice number to the left of 5, how about 0? So those will be my 3 values to test. So those just mean, I don't remember why that line was there. To plug 0, 6, and 10 into the equation that I'm wanting to check. Well, for us, these two expressions, these inequalities, are equivalent. So I can plug these values into either one. The thing that was catching us before, though, is the fact that I need to find my key values, specifically when it's set up like this with 0 on the right-hand side. Okay, so we can plug these values into either expression to test them totally up in the air. I'll do the second one since that one's 0 on the right-hand side, so maybe easier to compare these things. So we can plug in 0 and say -0 plus 8 all over 0 minus 5. Is this less than or equal to 0? Well, -0 is just 0, and plus 8 is 8. 0 minus 5 is -5. So is 8 over -5 less than 0? Well, yeah, that's -8/5. So that's a negative value, so certainly that is less than 0. Awesome. So this interval does pass our test. The next number to plug in is 6, +6. So let's do -6 plus 8. And then in the denominator, we have 6 plus 5. And this gives me 2. -6 plus 8 gives me +2 on top. 6 plus 5. Wait, did I do that right? It's minus 5. 6 minus 5 equals 1. And so the question is 2 less than or equal to 0? No, it's not. So this interval is not in my answer. And the last interval to check, we'll plug in 10 to get -10 plus 8 over 10 minus 5. And we can simplify that to -2 over 5. And we ask, is this less than or equal to 0? Yes, it is. Yes, it is. So that interval is valid. So my answer here would be everything from those two intervals together. We did that example with the union in class, -infinity to to 5 and 8. I ran out of room. To infinity. So that's why whenever we looked at the graph, it didn't really look like what it needed to for the answer that we thought we had with part C before. Okay. So again, in order to find the actual key values, we want 0 on the right-hand side. As this problem kind of warns us, we can see pretty clearly, I don't want key values of 0, but we can find on our own that my answer should be something about the square root of 9 plus or minus blah, 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 right? Making sense of it there. Okay, so let's handle this problem now, where what we're going to do to really find all of our key values is move this over so that it's just 0 on one side of the equation. So again, immediately, it is already correct to do what we said in that one top hat question. My key values are -3 and +7. So let's see if there might be any more that can pop up somehow. So if I do this, where I move 1 over x plus 3 to the left-hand side, then I get this, right? And the challenge right now is that maybe something new shows up if I actually combine these terms together. Well, right now they look pretty gross. So let me, right, in the sense that they have very different denominators. So let me maybe give us a little bit more space to write stuff down. And say 3 over x minus 7 minus 1 over x plus 3 greater than 0. And so because we want them to have the same denominator, I'm going to multiply each one by the other one's denominator. So that way on the bottom, they will end up with the same thing. So x plus 3 in the numerator and the denominator. Okay, so now I'm going to leave the denominator as x plus 3 times x minus 7, right? But we want to actually distribute across these terms. And what do I get? Well, 3 times x, I'll say is 3x. 3 times 3 is 9. And then on the right function, I'm going to do kind of 2 steps at once, because for one, I want to distribute the 1 to both terms. But hey, I also want to distribute the negative sign to both terms. So when I add those in, I'm going to get negative x and then positive 7, right? So I'm doing 2 steps at once. I distributed the 1, which didn't do anything, and then I distributed the minus sign to both pieces and wrote this as a single fraction. Now, what do we get? 3x minus x gives me 2x, and then 9 plus 7 gives me 16. And my denominator stays just like that if we so choose. And so now the expression is 2x plus 16 over x plus 3 times x minus 7. So as far as the question before of when would this expression be undefined, it's still at -3 and positive 7, right? Those 2 answers we found in that top hat question are still 2 key values. But another thing can appear. Is it possible for that fraction to be 0 Well, sure, if the top piece is 0. Can 2x plus 16 ever be 0? I'll subtract 16 from both sides. 2x is negative 16. Divide both sides by 2. And x is negative 8. So, yes, it turns out there actually is a 0 for this expression. Now, we wouldn't have really caught that before when it was written like this, which is the tricky piece. So we want to combine them into a single term so that way we can find possible zeros or whatever that wouldn't appear when we wrote it the other way. And so now we see we have 3 key values, negative 3. Oh, why am I doing that? I realize I have negative 8 is more to the left than negative 3. So negative 8, negative 3, and positive 7 are my key values. So how does this break up the number line? Well, I have negative infinity to negative 8, negative 8 to negative 3. I'm writing this one down here for the sake of room. Negative 3 to 7. And then from 7 to infinity. Okay. So before in class, we did find some representatives already. We plugged in 0, negative 4, and 10. So 0 would be in this interval, 10 would be in this interval, negative 4 is in this one, but we also want to test something in this interval, so we'll do negative 10. And that 4 looks a little rough, so let me fix that. So in class, when we tested these, we saw 10 did work, 0 did not work, negative 4 did work. So now this kind of new one to check would be negative 10. So if we plug negative 10 into, again, either expression, what do we get? Well, let me try the top one, the original one, and say 3 over negative 10 minus 7 greater than 1 over negative 10 plus 3. This combines into 3 over negative 17 greater than 1 over 7. And the question, negative 7. And this is a little tricky to answer, but I'm pretty sure the answer is yes. We can always go to our calculator. Sadly, I can't record myself doing this right now as what I type into the calculator that I have. 3 divided by 17 is 1 decimal 0.176, and that's negative. And then 1 divided by 7 is 0.143. Okay, so my first guess ended up being wrong. This is a more negative value than this one, right? So we drew them on the number line. This would be negative 1.76 to the left, and then negative 1.43 to the right. So this is not true. That does not hold, so this interval does not hold. Okay. Whew. So the last thing that I do actually want to check here is what about this edge case where x was equal to negative 8? What happens there, right? What about in the intervals in between? Well, I know already that's not going to be true because the whole point is that this solution came from this one. where that expression equals 0? Well, again, these are equivalent expressions. So when we say that this must be greater than 0, I already found where it's equal to 0, so I already know negative 8 is not a valid number for the answer that we want, right? Maybe negative 3 would be, maybe 7 would be, oh wait, I can't even plug those into the equation. Or inequality, I should say. So in the end, my answers are the two intervals that it was valid for. So my answer would be negative 8 to negative 3 and 7 to infinity. So a little tweak to the answer that we got before, due to this fact that we didn't move the left-hand side over. But the tests were kind of good, good challenge for the interval notation. And again, I really just want to emphasize here, the thing that we need to do that we were neglecting before is make it 0 on the right-hand side. So the same way that we needed to have right, if we look at this expression, we kind of have an intuition about taking the square root gives me 3, and in fact this is a very valid approach. But the issue is if I just looked at it how it is, I might think my key values happen when x squared is equal to 0, which gives me x equals 0, and those are absolutely not the key values. Instead, I had to move negative 9 over and then see, oh, when is x squared minus 9 0, plus or minus 3? Those are the real key values. So that same thing happens with these weird fractions. So it's a little bit more work than we thought it would be at first, but certainly, yeah, we have to move these things over in order to be able to answer these questions. Okay. Yeah, I think that's where I'm going to stop it here. So I'm never good at ending these videos. Bye-bye.